Hello everyone, welcome to today's video. In this video, you will learn how to write a publisher node and a subscriber node using ROS file. Okay, so before implementing and writing the codes part, just just to get started, you need to have installed a Linux version, and in this case, I have used Ubuntu 20.04 version, and I have installed the Noetic ROS, which is supported by Ubuntu, and I have created a CatSkin workspace. So what is CatSkin workspace? CatSkin workspace is basically used for currently organizing nodes, packages, and it is for sharing codes and just to make our works easier and simpler. So in this CatSkin workspace, under the source directory, I have created a my robot controller package, and in this folder, under the source and in the script folder, I have created two Python files, which is circle.py and postsubscriber.py. So the circle.py is going to be our our publisher node, and the postsubscriber.py file is going to be our subscriber node. Okay, so publisher node is basically like a talker. In this case, it will just try to send some message and some directions, and the subscriber node is going to receive it and act according to the according to the commands that he is received or that it received by the publisher node. Okay, so let me just get into the codes part here. So I need to import the rospy. So after importing it, I need to create a function, and name goes to main, then so basically it is just initializing a node, and the headline that is very important in this case, what is the action that it is going to be or the direction it is passing to the subscriber node, and in this case I am just drawing a circle. So I am just drawing a circle using a turtlebot simulation that I will be discussing later on in this video. So after the initializing of node, I have to pass a login info. Okay, so the log info will be like this, that I have successfully started new publisher node. All right, so then I need to create a publisher, which is I have named it as pub, and I need to use a function in the rospy library, which is rospy.publisher. Yeah, the publisher, and here the publisher is going to take a name, so a name of the exact address that I am going to trace using the Linux bash, and then it is going to take a data type or class. Okay, so in this part it is very important to fetch the correct information. So I have created these four bash nodes. Okay, and I am just using this. All right, so here I am going to track the CatSkin workspace. Okay, so you can see that I have a source directory. So next I'll be directing that source, and under this we have this our my robot controller. Okay, so next I'm going to track this, my robot controller. Okay, so as you can see that here we have our scripts folder, and then I'm going to track these scripts, and here you can see our circle.draw.py and post_subscriber.py. So yeah, this is our the two files or the nodes that I will be using. Okay, so for the turtlebot simulation that we need to test those two working publisher node and subscriber node, I need to run a main ROS code which will be running throughout the entire process, and in another window I need to ROS run a turtle simulation, this turtle sim node. Yeah, you can see a turtle simulation that is displayed in this screen. Okay, and here I am going to fetch the important information about the subscriber node, and in this case first of all the publisher node. Okay, so for fetching info I need to type ROS topic list to check what is available in here, and you can see that the turtle one cmd file, this is our publisher node, and I am going to just fetch this, and I need to know some information about this, so I am going to use the ROS topic info and going to paste this, and it will show you that the data type of this is geometry message and twist. Okay, so I am going to copy this, and I have to the I am going to take a message using the ROS message, and it is going to show me the exact data type that we'll be using. Yeah, and it is the twist. Okay, so I have to import this twist in the next step, and before that I am going to just copy this direction here, it will be in the string. Okay, and then the exact data type, so be careful about using it, otherwise it will not work properly. So in this case it is the twist data type, and the size will be, let's say, 10. Okay, so I need to clarify what is the queue size. So the queue size is basically the buffer that will be will seeing when the publisher node will be sending information or any text or any command that will be received by the subscriber node. So the delay or the buffer is helpful for our larger message or a very large number of operations. So yeah, I will be taking it as 10. Okay, so you can see that it is showing me an error message, and because I need to import this twist data type first. So for this I am going to import it from geometry message as stated, and the message, and I need to import it from the message class, and it is twist. Okay, so you can see that the error message is gone and the code is running successfully till now. So for running the simulation properly I need to mention a rate, is rospy dot rate 2, and it is basically applying for all the commands and the rate of the actual simulation. And for to clarify it, I am going to use a while loop. For this the working will be the action or command will be passed down, and it will be continuing until I close the command. Okay, so it is basically keeping the function or the while loop, specifically the while loop in 2-unit rate. Okay, yeah, so this is just for clarification. And in our while loop I'm going to test that until our rospy program is shut down properly, I need to perform this operation, and this is the actual command part that is going to pass down to our subscriber node by the publisher node. So yeah, the message is in the twist data type. So I'm going to track that first of all, and my target in here is to create a write on node that will basically pass the command of drawing a circle in the turtlebot simulation. So what is the concept here? As you can see that it is a 2D surface, so I need to just upgrade the value of in the x direction in a similar matter or in a similar rate, and in this y direction I don't need to work, but I have to angular rotating this z axis so that it can easily draw a proper circle. Okay, so that is the logic here. So I am going to command it as it will be linear and x axis, and the unit maybe 2.0 will be fine, and the message in angular direction, and it will be at the z axis because z axis actually mm, you know it actually clarifies or refers to the z actual the rotation that we are going to see in the 2D surface. So it will be 1.0. So after that I need to publish a message using publish function, and the message will be displayed here. And yeah, finally I need to close the program. So until it hits the read sleep, the while loop would be continued and the command would be passed, and we can see that this message will be tracked for a long period of time until I close it. Okay, so let's just visually see it that how it actually happens. So here I have already get tracked the folder where the publisher node is located. So now I am going to run this Python publisher node file in Python free compiler, and the name is circle draw.py. Sorry, and I need to save this. Yeah, maybe I have done some mistake. So yeah, I have made a small mistake in our code, and this is actually going to be red capital. Maybe I missed slightly. Yeah, so this will work. So now if I run this program, yeah, you can see that the simulation has started and it is creating a circle, and until I give the command Control C, yeah, you can see that the node has been killed and the simulation has been stopped. So in this way you can easily create a write a publisher node. So now in the later part of this video I am going to write the subscriber node. So for writing the subscriber node, I have already created a file named postsubscriber.py, and I am going to write the code step by step. So first of all, I need to import rospy as before, and similarly, I need to use this name. Yeah, if it hits the main, then I am going to initialize a subscriber node. So the function is already like before, rospy init node, and I need to give a title, and in this case I can write that turtle pose subscriber. Okay, this will work good. After the initializing of the node, I need to store the value sub, and just to use this function for the working method of the subscriber node. Yeah, the subscriber, and from before I need to get the exact working path and the type of this subscriber node as well. So for that, this is our ROS code, so it will be continued like before, and in here I need to create a new simulation. So let me just stop this here, and I'm clearing this out. Okay, so yeah, I'm using the previous procedure. So the post subscriber dot py is now our destinated subscriber node that we are going to write. Here using ROS topic list, you can see that the turtle1 post path has been already there or listed as our ROS topic that we are working on. So this topic will be pasted here exactly, and I need to get the type. Okay, so for getting the type, I need to get the information about this. So ROS topic info will help us for getting the type. So yeah, here I have got the type post, so this will be pasted here. So I am repeating again, be careful about exact topic list and the data type using or writing the subscriber node and the publisher node as well. So before we have created a query site, but now we will use a callback function, and I need to write this function. So just before writing, let me just implement it, and the post callback will be the call. Yeah, so first of all I need to define this function, the callback function. So this post callback function will have the login info for the subscriber node. So the log info, so by log info, it is going to be the message that it is receiving from the publisher node. Okay, so it is just like a listener, and the publisher node is acting like a talker. Okay, so I am getting an error message here in post type because I haven't imported it yet. So I am have to import it from the turtle sim dot message. So from this class I can import the post data type. Okay, so yeah, this is the post data type. Sorry for the mistake. So this post data type will be here. Okay, so after that, after using the post data type and all the callback functions, I just have to use another log info that it is actually working correctly and receiving the message properly, and it will contain the text as node has already started working. Okay, so after the node already started working, so in the previous case I have used a while function and I have used the red.sleep function, but in this case we don't need to use any while function, except in spite of that I have to use the rospy dot spin. So what this is going to do, this rospy dot spin, before this rospy dot spin call, all the action will be done and it will be continued till it hits the rospy dot spin command. Okay, so this is going to be or supposed to be our last line of the subscriber node. Okay, so I think it's cool until now. So now I just need to start the turtle simulation. So turtle sim, this is ROS run the turtle sim, sorry, ROS run turtle sim, and the turtle sim node. Yeah, and we have got another turtle simulation and everything is done here. I just need to run that file. So I'm going to the workspace like before. Okay, so here you can see our source directory. So I'll be tracking the source directory, and under this I have my package, my robot controller. So I'll be tracking that in my next move. Okay, so after successfully tracking that, I need to use the source folder. So I need to track the source folder again, sorry, the script folder actually. So the script folder actually gets our 2 python 5. Okay, so the post subscriber file is going to be run here. So I need to run this python 3 post subscriber file. So yeah, you can see that it is working properly and giving this the message that it is working. Okay, so the node has already started working and it has stopped. All right, so here you can easily write the subscriber node and the publisher node that I have seen. So see you in the next video. Goodbye and happy learning.